All right, electrical circuits conceptual questions. We're going to do hopefully 1 through 6 in this video. We'll see how much I get rolling, and then maybe I'll do more, or maybe I'll break it up. All right, so first off, as a side note, these numbers here, this is the section that you'll find this information. So as far as number 1 goes, you should find that in section 1 of chapter, I believe it's 35, okay? The chapters look a little bit like this. They may change, year to year. Sometimes we get new books, we get rid of other books. So this is what it looks like. Chapter 35, I think it says page, this is 702. This is teacher edition, but you'll just have the white part rather than the part on the left side. Nevertheless, as I said before, the red circles with the numbers, this is the section in that chapter that you'll find it. If we get a new book, most likely it'll probably be in the same section, maybe a different chapter, but same section, because the information kind of goes from easy to a little bit more challenging. Okay, nevertheless, let's do number 1. Are all electrons flowing in a circuit provided by the battery? So I'm going to explain these a little bit longer. Like I said, if you want to speed through these by finding information yourself, go for it. It'll take me a little bit of time. So think about a closed system with pipes and water in it, where the water is the electrons, and then there's a water pump. So let's say we have our water pump. This is our pipe. This pumps the water, and then it goes back. Right? It's a closed system, so it goes in a perfect circle. Water fills up this whole thing. The water is the electrons. So the question is, are all electrons provided by the battery? Well, the answer is no for this. All the battery does is move the electrons that are already there. If we have a wire, a copper wire, there's already electrons in the copper wire. There's already electrons in the battery. The battery just provides a means to move the electrons, right? Just keeps the electrons flowing. Just like water in a pipe in a closed system, water's all the way throughout the pipe. The pump just moves the water. Also, like a pipe, electrons never cramp up or cluster up. They keep moving pretty smoothly, and they don't kind of compress at all, right? So if you had a straw and you put a bunch of metal ball bearings in it, when you push one in after the straw is full, it doesn't cluster up anywhere in the straw. It just, excuse me, it just pushes a bead, all these beads further to the right, and then the other one, if it's open, it'll just pop out or it'll just continue around, right? But it never clusters up, okay? So for number 1, our answer is no. And then if you want to explain that, you can, but in short, no. Okay, so number 2. Why must there be no gaps in an electric circuit for it to carry a current, right? So the answer to this is electrons are either moving or they're not moving. So just like we talked about a closed circuit where a pump is pumping water around, well, if there's a crack in the pipe, water will leak out, which is not the same with a circuit. With a circuit, it is because they don't bunch up, right? They don't accumulate anywhere. If this wire gets broken, so there's a gap in the circuit, then the electron flow just stops moving, right? So I think I drew this on an earlier video where, let's say you have a wire that's 1 atom thick, not really realistic. When one electron moves to the next atom, it moves over, electrons kind of repel each other, so that forces the next one to move over, and the next one to move over. So if there's a gap, everything will stop altogether. So, once there's a gap or there's a break in the circuit, it's just going to result in a complete stop of the flow of electricity. So it just stops. And that's really what a light switch does, right? When you turn the light switch off, it provides that gap, so there's a complete stop. Your light doesn't dim, it just shuts off, right? And when you turn it on, the circuit is complete and the light completely turns on. Okay, number 3. Distinguish between a series circuit and a parallel circuit. So distinguish means like, hey, tell the difference between. Okay, this is another one we talked about. Let me see if I can find my drawing. Hopefully I can. Awesome. So distinguish between a series and a parallel circuit. So if you remember what parallel means, it means the bulbs or whatever is going to be hooked up in a parallel form, just like this. So there's going to be kind of like multiple connections where if I break one, let's say I break this right here, that doesn't necessarily mean this light bulb is going to turn off for this filament. It won't, right? Whereas in a series, if I break one, the whole thing turns off, okay? So in short, a series has one pathway for electron flow. Boom, just one pathway, whereas a parallel circuit has separate pathways. In other words, if one stops, it doesn't shut down the whole operation, okay? So there you go. So that's number 3. All right, number 4. So we know number 4 is in section 3. If 3 lamps are connected in a series to a 6-volt battery, how many volts are impressed across each lamp? So 3 lamps, boom, 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 are on a series circuit. So we know a series is the one that just goes all the way around just like this, right? So we have 3 lamps. They're connected to a series. We have a 6-volt battery. How many volts are impressed across each lamp? In other words, how many volts are put on each lamp? So here's the answer to number 4, right? So if we have the total voltage across a series circuit is always divided by the individual electronic devices in the circuit. So in other words, the total voltage divides by the number of things using it, the number of light bulbs, we'll say in this case. So that the sum of the voltage drops across the individual device, it's equal to the total voltage supplied by the source. So in other words, if you added all those together, added all those voltage, put it across each lamp, we'll say, it should equal the total voltage, okay? This follows from the fact of the amount of energy used to move each unit of charge through the entire circuit equals the sum of the energies to move the unit of charge through each of the electric devices in a circuit. So in other words, you're going to take your total voltage, which is 6 volts. Okay? You're going to divide it by the number of lamps in this case, divided by 3 lamps. And then that should equal the voltage across each lamp, which will be 2 volts. Okay? So that's pretty simple. Remember, the only thing you need to remember for this one, this is when you're dealing with a series. Okay? This is when you're dealing with this kind of circuit. Series. Okay? I ain't going to write out parallel, but series, parallel. Okay? So when you are dealing with a series circuit, you take the things using your electricity and you divide that into the total volts. So then across each one is going to be 2 volts. So that one's pretty straightforward, pretty easy. You'll definitely use this. I'm pretty certain you'll use this in the future, but there you go. Okay, number 5. We kind of talked about this earlier, so let's see if you remember it. If one of the 3 lamps blows out when connected in series means one after another, right? So this is our series with 2 lamps, so just imagine another lamp right here, okay? So if one of the 3 lamps blows out when connected in a series, what happens to the current in the other 2? Well, remember, in a series, everything is just in line, so if one of the lamps blows out, that is going to cause an open circuit. In other words, there's a place where there's no connection, which means the flow of electrons just stops. Just like if you turn off a light switch, it breaks that connection, so there's no flow of electrons, so there's no light in that case. So your answer would be if one lamp blows out, the current is just going to stop, okay? All right, number 6. If 3 lamps are connected in parallel to a 6-volt battery, how many volts are impressed across each lamp? So let's do our highlighting real quick. So remember, we're doing 3 lamps, same amount of lamps, connecting in parallel, so it's a parallel circuit, and then it's to a same 6-volt battery. How many volts are impressed or put across each lamp? All right, so let's move this up a little bit. So if 3 lamps are connected to a parallel 6-volt battery, how many volts are impressed across each lamp? So remember, our parallel circuit looks like this. So each lamp, remember, let's say this is the battery. Each lamp is independently connected to the battery, which means that if I cut this right here with scissors, metal scissors, crazy, this lamp will continue to go. It'll continue to be lit because it's independently connected to this battery. This one will not be because I've cut the line, but this one will continue to be lit. So in that case, each lamp will have 6 volts across it. Okay? So that one's pretty straightforward. No tricks for this one. So if 3 lamps are connected, this is only in a parallel circuit with a 6-volt battery. How many volts are impressed across each lamp? Well, since they're all independently connected, the voltage will be the same across every lamp. That doesn't mean everything else is going to be the same. That just means voltage will be the same across each lamp. Okay, so I'm kind of on a roll, so I'm going to keep going. As I said, if this stuff is easy for you and you're like, man, I think I could do this so much faster than he's explaining, hey, abandon the video, look it up on your own. You'll probably move much faster than I'm moving. This is just a slower pace for the students that like to hear it rather than, go find it. So let's move on to question 7. Awesome, we kind of covered this already. So question 7, if one of the 3 lamps blows out when connected in parallel, what happens to the current in the other 2 lamps? Okay, so our parallel, hopefully you remember, is this bottom one here. This is our parallel. Notice parallel, they're all independently connected. So if one of them blows out, so let's say the filament in this light blows out, boom, stops working, right? What happens to the current of the other 2? Well, remember, they're independently connected, so the current will just continue to flow. It's not going to be affected. In other words, the light, if our left bulb blows out, stops working, our right one will continue to blow. It'll continue to flow, excuse me. So that's why that's usually, I want to say with Christmas lights, I want to say, and come let me know if I'm wrong on this, they switch the cords to kind of a parallel type of design. So that way if you have your Christmas lights up or whatever lights you have up and one of them blows out, it doesn't turn your whole setup off. It just turns that one off. Because remember, if they had it in a series, imagine how much that would suck. One of your lights blows out, all of them turn off, and especially if it's just a filament, you have to check every single filament to find the one that burned out, and then you can fix it, and then the whole thing's on again. That would not be fun, okay? So that's why it's kind of an interesting thing to know, like how things work and why they would do, okay, why would you do parallel versus series? Okay, so let's look at number 8. 8A, 8B. So these are both in section 4. In which case will there be more current in each of the 3 lamps if they are connected to the same battery in series or in parallel? Well, same current, okay? So with this one, remember, with series they're sharing, with parallel they're all independent. So when they're independent and they're not sharing, there's going to be more current because the current's going to not be reduced, right? So in that case, A is parallel because the current won't be reduced. Let's look at B. In which case will there be more voltage across each lamp? Same thing, parallel, more voltage, and we just talked about that one. Because they're independently connected, the voltage will be the same across each one. So like we did in, I don't know what was that, number 6, I think they were all 6 volts in number 6, right? So there's no reduction of voltage there. So that one's parallel as well. Okay, let's go to number 9. What happens to the total circuit resistance when more devices are added to a series circuit or to a parallel circuit? So the total circuit resistance. So we're talking about resistance. So remember, in the total circuit resistance, let me just highlight some stuff. in a series, because they're not independent, because they're kind of all relying on each other, as you increase the devices in a series, you're going to increase the resistance. Okay, so let's kind of break down number 9 a little bit. The equivalent resistance in a series is just a sum of their values. So with that being said, if you had something like boom 8, and that's or whatever. Let's see. Let me draw this. Here, let me do this. So I'm going 8, 8. Okay. So my equivalent resistance in a series, just straight up, would be 16. You just add them up. Okay. So think of it as the total resistance, like if there's one door out of an auditorium, it's just going to be straightforward, the amount of resistance. Maybe you have 2 pathways flowing into it, but there's only one door. So it's just the more pathways, that's kind of confusing, but just know that in a series, you just add them up, straight up. Parallel is a little bit different. Parallel is where it gets a little bit tricky. With parallel, it's a little bit different. Parallel is the equivalent resistance of a pair of equal resistors in a parallel circuit is half the value of either resistor. So let's draw that out. So if I had a resistor that looked like this, it goes up, same 8, comes back down, this is 8 as well. In this case, the total resistance would be 4. So let me repeat that, because I know that's very confusing. At least it was for me when I first learned about this. So the equivalent resistance for a pair of 8 ohm resistors in a parallel circuit is 4. The equivalent resistance for a pair of equal resistors in a parallel circuit is half the value. And the reason being, like, for that is, think about, like, again, you have an auditorium full of people. The resistance is less because the current has twice the path width. In other words, if everybody's trying to exit, if there's 2 doors, if there's double the amount of doors, there's less resistance, right? Just like if you have a highway and you're trying to exit and it's usually clogged. Let's say there's an exit on the right and there's an exit on the left. Well, there's going to be less resistance, assuming everybody was super coordinated, right? So just remember that if there is the equivalent resistance of a pair of equal resistors is half the value of either resistor, okay? So in a series, you add them together. In parallel, if they're equal, it's half of one of their values, right? So it's 4. So if the resistance is 1 in a parallel circuit, or each one of these equals 1, then the resistance would be half an ohm. Okay, so don't freak out if you don't get it. Just keep having experiences with it. Keep looking at it. Keep seeing it. It'll get easier. Okay, so no worries. So as far as our answers are concerned, what happens to the total circuit resistance when more devices are added? In a series, that increases. In a parallel circuit, it decreases. Okay. Okay, so let's move on to number 10. We kind of answered 10. Let's do it again. What is the equivalent resistance of a pair of 8 ohm resistors in a series and then in a parallel? Remember, in a series, you added them together. So we're talking about a pair of 8. So that means 2 8 ohm resistors. In a series, 8 plus 8 equals 16, right? So that's 16. In a parallel, so you have an 8 and an 8. So your resistance is half of one of them, which, since they're the same, they should be the same, it's 4, right? So 16 for the series, parallel should be 4. Okay, why does the total circuit, number 11, sorry. Why does the total circuit resistance decrease when more devices are added to a parallel circuit? We kind of answered this already. Think of it, it's just more pathways for electricity to go. Because the total current in a circuit equals the sum of the current in the parallel branches. So again, why does the total circuit resistance decrease when more devices are added to a parallel circuit? Because there's more pathways. So the resistance should decrease. It's like adding more doors to an auditorium. The resistance will be easier. People will be able to get out a lot easier. All right, number 12. What does it mean when you say that lines in a home are overloaded? Okay, so when you overload a line in a house. Okay, so with 11, okay, so why does the total circuit, are we on 11? No, we're on 12, sorry. Are we on 12? Let's see, we did 10. 11, what is the total circuit resistance? Okay, we did 11, let's go to 12. Sorry, I pause and then I regroup sometimes and then it makes me forget where I was. All right, number 12, what does it mean when you say the lines in a home are overloaded? So remember, homes are in a parallel circuit. You wouldn't want it in a series because if something stops working, then your whole house shuts down, right? So they're in a parallel circuit. As you increase lines in a parallel circuit, as we said before, it's like adding doors to a coliseum or whatever, you decrease resistance. So when you add too many things, you plug in your toaster, your refrigerator, your dryer, you turn everything on, your resistance decreases quite a bit, which means you have an extremely high flow of electrons, which means wires start heating up drastically and, things can melt, things can catch on fire. That's why you have breakers, right? So let's put it formally. The additional pathways of devices lowers the resistance, what we said, increasing the current in the lines, and they can carry an unsafe amount of current, which, again, melts things, heats up lines, so that's why parallel, you don't want too many pathways without adding resistors. All right, number 13, what is the function of a fuse or circuit breaker in a circuit? So remember, the function of a fuse, like we said, when you have too many lines open, it increases the current to dangerous levels. So it opens the current when there's too much current going through it. That's the function. Why would you want to do that? Because you want to stop that flow. Sometimes when it gets cold, I'll turn on my heater, I'll turn on space heaters, and too many space heaters in one circuit of a house, it pops it. And then I can see one part of my house just shuts down because there's too much current flowing through. Okay, so that's why that does that. All right, let's go to 14. Why will too many electrical devices operating one time often blow a fuse or trip a circuit breaker? Okay, awesome. We're answering multiple questions in one question. That's good. So again, same thing. When you have a bunch of devices operating at one time, it increases the current moving through the circuit. Again, you don't want the current moving through the circuit too fast because it heats things up, melts things, catches fire. So the fuse, the circuit breaker trip, that's like a fail-safe. Sometimes they'll have them in individual devices, like a heater, for example, will have a built-in deal. If it gets too hot, boom, it trips that thing, it turns off. So that way it can have a chance to cool down. When you got too many things flowing in your house, it trips your circuit breaker. Just to say, whoa, too much thing's flowing, it's heating up too much, you got to chill with that, okay? So it trips it to turn everything off. And it also lets you know, hey, that's not a good idea to have that many things pulling that much power, okay? All right, 15, what does it mean, or what is meant by a short circuit? So a shortened circuit path, it draws dangerously large currents because it bypasses the normal circuit resistance. So again, what does it mean? What is meant by a short circuit? A shortened circuit path that draws dangerously large current because it bypasses the normal circuit resistance. Okay? Okay, let me go over this real quick and then we'll be done with this section. So with a short circuit, let's say you have a couple of wires and that insulating part around the wire, like the plastic part, insulating means it keeps things in and keeps things out. Keeps the current in. Maybe it wears away and so wires can touch. Now what that does is it lets the current flow with a shorter path, which means a path that has also a lot less resistance, right? So because it's flowing over a shorter path, it can allow a dangerous amount of current to flow through, again causing like fires and things like that. So think about it like this. If I had an auditorium and I had two doors pretty close to each other, so a certain amount of people can come out, a certain amount of flow can go out of those doors. Eventually, let's say the wall in between those two doors just got deteriorated over time, so now it just becomes one giant door. This is kind of a weird analogy, but we're going to go with it. And now you have a dangerous amount of people flowing out this one huge open door, or whatever, it speeds up the pathway. And now people are getting trampled, things are getting dropped, but you can't go back, and just it causes a lot of problems. Same concept. The wire goes a different way because remember, things go the path of least resistance. So the wire, the current's going to flow over this other wire, a lot less resistance, which means there's a lot faster flow, a lot more flow, and things heat up, fires catch. So hopefully this helps, guys. I know it was long, but like I said, I make these videos for the individuals that want more understanding and want to go at maybe a little slower pace, because sometimes you just, especially with concepts like electricity, you want to hear it. You want to hear it broken down and talked about. So if this is something you're like, hey man, I don't need this and I want to move faster, hey, don't watch the video. Just go look it up, do it. You can do it really fast. And if you need the video, that's fine too, because this is like what, maybe half a class. So, all right guys, hopefully this helped.